Hello, good morning, all of you. Okay, this is the fifth question. Earlier, you learned four. Okay, distinguish between cortical nephrons and juxtamedullary nephrons. Okay, one MCQ was also given in NTA mock test papers regarding cortical nephrons and juxtamedullary nephrons. Cortical nephrons. The loop of Henle is too short here. Okay, if you observe here in these nephron, this is the loop of Henle. Okay, loop of Henle is very short in these nephrons. Okay, loop of Henle is what type of loop of Henle is present here? Loop of Henle is short. It is useful for objective also. Okay, this is the loop of Henle. The loop of Henle is short here. Loop of Henle is too short. And observe here, loop of Henle is very long. Loop of Henle is very long here. Loop of Henle is short. And loop of Henle extends only very little into medulla. This part is medulla. This part is medulla. It extends only a very little into the medulla, but it runs deep into the medulla. Okay, here it runs deep into medulla. Here it extends only very little into medulla. Here it runs deep into medulla. Loop of Henle is too short. Loop of Henle is very long. Extends only very little into the medulla. It runs deep into the medulla. Renal corpuscles are located in the outer cortex. Renal corpuscles are located in the outer. This is a renal corpuscle. Renal corpuscle is in the outer part of the this is the cortex, but it is in the outer part of the cortex. This is the cortical nephron. This is the juxtamedullary nephron. Here renal corpuscle is here, but renal corpuscle here is here. You could look at the difference here. Renal corpuscle is not in same position here. Renal corpuscle is very next to the medulla. That's why it is called juxtamedullary nephron. Okay, you can observe here. It has a long nephron, It has a long nephron loop, and it has short nephron loop. That means Henle's loop. Okay, renal corpuscles are located in the outer cortex here. Renal corpuscles are located close to the medulla in the inner cortex. Close to the medulla, and this is the outer cortex. This is the inner cortex. Here, renal corpuscle is in inner cortex. It is in outer cortex. Another point. Vasa recta is absent or highly reduced. Okay, these are many in number. 85% nephrons in our kidney are this type, and 15% of the nephrons are this type. Okay, these are more in number. Cortical nephrons are more. These are less in number. Okay, next one. These are many in number. These are few. These nephrons are few in number. Which nephrons are few in number? Juxtamedullary, because they are only 15%. These are 85%. It was also asked in previous mock test paper NTA. Okay, next vasa recta is, vasa means blood vessel, recta means straight blood vessel. Vasa recta is absent, highly reduced. Okay, you can observe here vasa recta is not present here. Okay, this blue color network like such. This is the vasa recta. Vasa recta is well developed here. Okay, vasa recta is absent there. Here not present. Okay, here vasa recta is well developed here. Okay, that is the first one. What is glomerular filtration? Very important, these two. Filtration of blood through the fine slit pores and fenestrations due to net filtration pressure. What is the net filtration? Can you tell me? That is 10 mm Hg of Hg, 10 mm of Hg, mercury. Fine filtration of blood through the slit pores. Where are slit pores? Slit pores are present between the podocytes. Where are fenestrations? Fenestrations are present in the capillary. I told you three types of capillaries: continuous, discontinuous, and fenestrated capillary. Fenestrations are the small pores present in the capillary wall, and fine slit pores are present between the podocytes. Filtration of blood through Filtration of blood through what? Through fine slit pores and fenestrations are due to net filtration pressure. Okay, by passive process from the glomerulus into the lumen of the Bowen's capsule is called what we call it, glomerular filtration. You have to divide this point, then you can understand. Filtration of blood through through fine slit pores and fenestrations due to net filtration pressure by passive process from glomerulus into lumen of the Bowman's capsule. What kind of process is this one? Passive process, and it is occurring through fine slit pores and fenestration. It is occurring due to net filtration pressure. From where to where? From the glomerulus into lumen of the Bowman's capsule. What do we call this filtration? This is called glomerular filtration. Next one, glomerular filtration rate. What is meant by GFR? The amount of filtrate formed by both kidneys per minute is called glomerular filtration rate. The amount of filtrate formed by the volume of filtrate produced by both kidneys per average GFR is 125 ml per minute. Total for day 45 gallons. That means 180 liters. 180 liters per that is the GFR per day. So most filtrate water must be reabsorbed or death would ensure from water loss through urination. GFR is directly proportional to NFV. Okay, what type of proportional here? It is not inversely proportional, it is directly proportional. GFR is directly proportional to net filtration pressure. Okay, if the net filtration pressure increases, if NFP increases and GFR also, glomerular filtration rate also increases, it is directly proportional. An increase in GFR can increase in NFP, net filtration pressure increases the GFR. A decrease in the NFP decreases, it also decreases. Okay, changes in GFR normally results from changes in glomerular blood pressure. Okay, NFP full form net filtration pressure. Okay, that's about glomerular filtration rate. The amount of filtrate formed by both kidneys per minute. Not 1 hour, is called glomerular filtration rate. It is approximately 125 ml per minute per day, 180 liters. Okay, next one. Okay, those are the three questions. What are those three? What we learned here? Difference between cortical nephrons and extramedullary nephrons. The next one, glomerular filtration rate. These two are very, very, very important. They were asked in previous I papers.